flipping a coin could either be heads or tails, right? So that's why we call it binomial. It's a binomial distribution because when you list out the probabilities of all those different outcomes, the most likely outcome is you get 8 heads, 8 tails, but it's not too unlikely to get 7 heads and 9 tails or 9 tails and 7 heads, right? And so if you graph it, it looks approximately like the normal distribution. But it won't be perfect. And since it's not perfect, we're going to use something called the continuity correction to help us. So you want to keep that in mind for this. It's the normal distribution, but we need the continuity correction. Okay. Approximating the binomial distribution with a normal curve. What is the probability? So they give us that the mean is 8 and the standard deviation is 2. What's the probability of flipping a 9 or a 10? So we need to actually check to see the probability between 8.5. So I subtracted 9 by 0.5 and between 10.5. That's the continuity correction that we're supposed to use when we use the normal distribution to approximate the binomial distribution. Okay, that's pretty nerdy, but in summarizing that means whenever you have a binomial distribution and you're trying to use a z-score table, to apply the normal distribution, you've got to subtract the 0.5 from the lowest number and add 0.5 to the highest number. And so we want to know the probability between these two z-scores. Okay, so to do that, look, the mean is 8 of this distribution, right? We expect 8 heads. That's the average. So 8.5 is somewhere a little bit to the right. And then 10.5 is somewhere also to the right. We want to know this area in the distribution of the probabilities. Okay, so to do that, we're going to look up the z-score values using that continuity correction that we talked about. 8.5 is the first one we're going to look up, and then 10.5 is the other one. So if you look in this table, a z-score, actually first, these aren't z-scores yet, sorry. Those are the values we want to look up in the table. And so we can only look them up once we convert them to those z-scores. Okay, so same distribution, it'll be the same area, except we're going to convert 8.5 to a z-score. That way we can use the table. And to do that, we use the z-score formula. We take the particular number we're transferring to a z-score. We subtract it by the mean, which is 8, set up above. And then you divide by the standard deviation, which up above it said was 2. So once you make that computation, you get 0.125. So that's the first z-score. Next one I'll type out so it's easier. We get 10.5 subtracted by the mean, divided by the standard deviation. So that's 2.5 divided by 2. That's 1.25. So there's our two z-scores. Now we can find out their associated probabilities by looking up at the table. So 0.25, here's z of 0.2, and then here's 0.5. So 0.25 gets us right here. Remember, when you use a standard normal table, they usually are saying the probability to the left. Since it's a little bit above 50%, that is what this one's indicating. So I'll use a different color. We just looked up this z-score of 0.25 in the table, and we found out that 0.5987 is to the left of that z-score. Okay? So 0.5987 is to the left. And then if you look up the other z-score of 1.25, here's 1.2, here's 1.25. That's the probability of being less than this value. And so that covers all this area. Now we wanted just this area in between, right? Just this stuff right here. So you're going to get that by subtracting the blue area by the red area. The bigger one subtracted by the smaller one. When you do that, then you've got your probability that they're looking for. 0.2957. That's the probability of flipping a 9 or 10 using the continuity correction, 0.2957.